Welcome back to the deep dive. If you've ever wondered what the actual blueprints look like for high-performance AI integrated software today, in 2024, you are definitely in the right place.
Yeah.
We are going deep into the architecture of three fundamentally different enterprise-grade projects.
It's an incredible study in contrast, but also convergence. We have an AI video learning portal. We've got an AI prompt generator, which is fascinating, and then a full-scale vehicle fleet management system.
So e-learning, creative engineering, and real-time telematics, they couldn't be more different on the surface.
Goal, diversity, and function.
Yet, when you stack the source material side by side, the architectural DNA is, well, it's shockingly similar.
It really is.
So our mission today really is to pull these blueprints apart. We want to show you exactly how they're leveraging specialized microservices, these polyglot backends, and just intense data automation.
To deliver these really complex, high-performance capabilities, things that, monolithic applications simply cannot do anymore.
We can't keep up.
Absolutely not. The unifying factor here is scale and specialization. These aren't simple apps. They're cloud-native solutions. And that requires, well, it requires an intense focus on modularity.
So let's start right there with that foundation.
Let's go.
The architectural choices that really define these platforms. When we look at the core stack, the first thing that really jumps out is just the sheer lack of commitment to a single framework.
Right. We are deep in the era of the polyglot backend.
You really are.
And the video tutorial portal is, I think, a brilliant example of this. They aren't just choosing one programming language. They're choosing the best tool for the specific job that needs to be done.
Okay, so walk us through that stack breakdown, because it truly defines what architectural specialization means.
So you see this mix of technologies, and they're all coexisting happily in their own containers.
Yeah.
You've got Node.js with Express.js handling standard core API functions.
User sign-up, course descriptions, that kind of thing.
Exactly, the basics. But then, for anything that requires really high I/O throughput, like the actual serving of video files, they switch to Fastify.
Okay, so why Fastify for video? Why not just stick with the existing Node and Express API?
Because Fastify is just built to be leaner and, well, faster. It's specifically for high-performance data delivery. When you're streaming video to maybe thousands of concurrent users, milliseconds matter. Express just carries more overhead.
Right.
But the specialization doesn't even stop there. For the really advanced capabilities, like the core logic for, say, search indexing or user authentication, they pivot again, this time to Python, using FastAPI.
So the developer teams are building these pieces in totally different languages, but they all communicate through standard APIs, which allows them to optimize performance right down to the feature level.
Exactly. It's a strategic architectural decision. Now, compare that to the fleet management platform, VxCare. They chose a more unified approach. It's built primarily on the .NET 9.0 and ASP.NET Core stack. And that offers its own benefits, in terms of developer consistency, integration within the Microsoft ecosystem.
That brings up a great question about the trade-offs, right? Why would VxCare stick to one framework while the video portal embraces this polyglot zoo?
It likely boils down to the nature of the data and the development environment. VxCare is dealing with mission-critical real-time data where transactional integrity is, it's paramount.
Everything has to be perfect.
Right. So while they're still using microservices, using a unified, strongly typed framework like .NET helps maintain predictable performance, and honestly, it simplifies managing enterprise-grade security and data isolation. We'll get to that later.
But no matter the language, they share that infrastructure DNA.
Yeah.
MongoDB is the primary database, and everything is containerized with Docker.
And VxCare specifically calls out MongoDB 7.0 Plus and Kubernetes.
Kubernetes.
And that's the key signal right there. The moment you move to Kubernetes for orchestration, you are signaling some very high-level requirements. You're talking automated scaling, self-healing, resilience.
Let's go back to the deep specialization of the video portal for a second, because it illustrates the microservices idea perfectly. We're not talking 2 microservices. We're talking 6 distinct containerized services just to manage content.
And that specialization is strategic. Think about what that buys you.
Fault isolation.
Exactly, fault isolation. If your metadata update agent, which is just responsible for scraping and enriching course data, if that crashes, your content server is still happily streaming video. The user never knows.
You're isolating risk.
Precisely. And one of those 6 agents, the metadata update agent, is actually a REST API wrapped Node.js service. It uses the Cheerio library. Its single job is to automatically go out to web course URLs, scrape data like titles and descriptions, download the preview images, and then update the MongoDB record.
That's an intelligent automation bot.
Dedicated to content ingestion and enrichment.
Yes. That's a perfect pivot point. The true difference between a modern platform and a standard application isn't just how you structure the code, it's what that code does automatically.
This is where these platforms truly separate themselves from the pack. They don't just sit there and wait for a human to input data. They actively create it, process it, enrich it.
So let's stay with the video portal and its content agents. Besides the web scraping service you just mentioned, what other kinds of automation are running back there?
The other critical component is the course content scanner. Now, this is a Python CLI tool, so not an HTTP endpoint, that recursively scans folder structures, it extracts metadata from the video files, and most importantly, it handles SRT subtitle processing.
Okay, so why is processing SRT subtitles such a huge architectural deal? It sounds pretty simple on the surface, but it's clearly foundational for AI.
It is the foundation.
Yeah.
An SRT file is just data and text, right? By processing and normalizing all those transcripts, the platform is preparing the data for advanced indexing. This is what enables lightning-fast, deep search across all the content.
It's the prerequisite.
It's the prerequisite for everything else. For embedding vectors that power future AI, features like semantic search and automated summarization. If your input data isn't clean and structured, your AI outputs are going to be garbage.
And structuring input data, that is the entire reason the AI prompt architect platform exists, isn't it? It solves that garbage in, garbage out problem for LLMs.
What's so fascinating about the prompt architect is that it acknowledges the modern struggle.
Yeah.
Which is, how do you give a complex model all the necessary context from a huge array of source files without just, pasting 5,000 lines of confusing text into a chat window?
So give us an analogy. What does the prompt architect actually do for a user?
Okay, think of it like this. If you're a chef, you don't just dump all your raw chopped ingredients randomly onto the counter and then tell your assistant to make a complex sauce.
No, of course not.
You organize them into labeled bowls, measured and ready. The prompt architect is that organization system. It gives you a clean, VS Code-like folder tree interface where you can visually select exactly which source files are relevant.
So instead of copy-pasting code snippets or documentation, I'm just clicking on the files I need.
Exactly. And the system automatically takes those selected files, combines them with structured, user-defined inputs, the role, like act as a senior Python architect, the task, and the requirements, and then it just seamlessly assembles them into one highly organized, markdown-ready context block.
Ah, it's slick.
It also offers persistent state-saving and ZIP export so that carefully constructed prompt package can be shared with colleagues or, saved for later. It's automation designed to optimize human-to-AI interaction.
Okay, so we have platforms automating content input for humans, like the video portal, and automating content input for the AI, like the prompt architect. But VxCare is all about operational intelligence from data that's, literally moving at 60 miles an hour.
And that requires a completely different processing approach. It's all about real-time intelligence. VxCare uses SignalR for instantaneous telemetry updates. We're talking GPS coordinates, speed, engine diagnostics, all of it streaming live.
Why SignalR or a WebSocket solution like it? Why can't they just use, regular repetitive HTTP requests?
Latency, just pure latency. When you're tracking a fleet of trucks, a few seconds of delay, which is totally common with standard HTTP polling, is just unacceptable.
Right.
If a driver suddenly brakes hard, the platform needs to know that now. SignalR maintains a persistent connection, so the server can push data instantly to the client. That low latency is absolutely essential for their intelligent features.
Which includes some pretty sophisticated analytics. So give us an example. How is that real-time data being processed into something actionable?
A key feature is the driver behavior analysis. It uses algorithms to score driving patterns, harsh braking, rapid acceleration, excessive speeding, to assign a safety and efficiency score to that driver. And on top of that, they use geofencing. This means defining virtual geographic boundaries, and when a vehicle crosses one, it triggers automated entry and exit alerts. This isn't just passive tracking, it's using real-time processing to actively influence operations and safety.
That immediate feedback loop is so critical, and that pushes us right into our next part. Performance delivery and the user experience these architectures make possible, speed and data integrity have to be flawless.
They absolutely must be. We already mentioned the use of Fastify in the video portal for sheer speed in the courses portal content server. But what if your video library is so huge that the files have to be stored across, say, several different physical storage systems?
That sounds like a management nightmare from a single server.
It would be, but the system uses UnionFS. Think of UnionFS like creating one gigantic, seamless virtual folder on your computer that's actually pulling files from 10 different networked drives.
Ah, okay.
This lets the content server aggregate all those video files from multiple sources under one single access point. So you get quick, reliable access for streaming, and the user never even knows the content is physically distributed.
And that seamlessness is reflected in key UX features like the Netflix-style continue watching function.
Which relies on specific, fast endpoints like GET-AP1 continue watching.
And that quick resume feature or any stateful update that demands data integrity, which is where we see that enterprise-grade API optimization you mentioned, specifically ETAG-based optimistic concurrency control.
Yes, that's a mouthful, I know.
It is a mouthful. So for those of us who aren't deep in API architecture, what problem does this solve in a practical sense? Why is it so important for a platform like VxCare or the video portal?
It solves the stale data problem. It does it in a high-traffic environment without forcing users to wait around. Imagine you're updating a setting for a course, or maybe you're changing the max speed limit on a VxCare vehicle profile. Optimistic concurrency just assumes that conflicts won't happen that often, but when they do, they have to be resolved without corrupting the data.
So how does the ETAG actually handle that?
Every record gets a unique digital fingerprint. That's the ETAG. When you download a vehicle profile, you get its current fingerprint. When you submit your update, the system checks if the record on the server still has that exact same fingerprint. If it doesn't, meaning someone else updated in the split second you were making your changes, your update gets rejected. And you just get a polite message asking you to refresh and reapply your changes. It guarantees consistency.
That seems essential for a large enterprise platform. And speaking of enterprise must-haves, VxCare also highlights its multi-tenant architecture.
That is absolutely non-negotiable for a fleet management system. Multi-tenancy just means the platform is serving multiple independent organizations, say DHL and FedEx, from the exact same underlying infrastructure. But
their data has to be completely isolated.
Completely. It's like a shared skyscraper, where every company has its own locked floor, even though they all use the same elevators and lobby.
That's a great analogy.
It is. This organization scope data isolation is a foundational security and business requirement. I mean, if you're handling GPS coordinates and sensitive operational data, you have to ensure Company A can never, accidentally or otherwise, see Company B's vehicle locations or driver scores.
And on the front end, the UI really reflects the seriousness. The video portal is using modern React with Next.js 14, focusing on performance with the app router and TypeScript.
And the prompt architect, while maybe less complex on the data volume side, puts a huge amount of effort into providing a desktop-like experience inside the browser. It uses resizable panels, bold labeling, a layout that's really designed to mimic professional productivity tools. They know their audience. They know they're there for deep work, not casual browsing.
So we have these specialized services delivering hyper-specific performance, and it's all guaranteed by enterprise-grade data controls. But their roadmaps show they are nowhere near finished.
Not even close.
So let's look at part 4, the trajectory. The future is very clearly defined by pushing the limits of AI and scale.
The future vision for all three of these platforms is, essentially, the complete integration of intelligent automation. And the video portal's roadmap is aiming for a complete transformation of their service.
What's the AI focus in the short term for them?
In Q2 2024, it's about enhancing discovery, so content recommendations, automated summarization. But the big architectural push comes in Q4 2024. That's when we see advanced AI features like natural language query processing and automated assessment generation.
Wow, that fundamentally changes the service from just a content library to an active teaching tool. You aren't just delivering a video anymore. You're generating a quiz that's tailored to what the user just watched based on an AI's analysis of the transcript.
And their ultimate goal, fully personalized AI tutors. The platform would handle content delivery, assessment, and personalized instruction, all autonomously.
Meanwhile, VxCare is taking all that real-time data and translating that operational intelligence into predictive capability.
And that is the most valuable step in telematics. Moving from knowing what is happening to predicting what will happen. While their medium-term focus includes essentials like mobile apps, the core objective is predictive maintenance.
So using machine learning models.
Exactly. Trained on sensor data to predict component failure before it actually happens.
So instead of a truck breaking down on the highway, The system tells you it will break down next week, so you can schedule the maintenance now.
That's the holy grail. And the long-term vision includes AI-powered insights for advanced anomaly detection and route optimization, using machine learning to shave seconds or miles off thousands of daily routes, all at once.
Looking at both of those roadmaps, the plans for scale are massive, and they seem to share common challenges, whether they're streaming video or tracking trucks.
The scaling infrastructure is identical. The video portal roadmap specifically calls out CDN integration for global video delivery, database sharding to handle massive data volume, and implementing sophisticated caching layers. VxCare is also planning for multi-language support and expanded IoT device integration.
They're all building globally scalable infrastructure to support globally intelligent services.
That's the plan.
This has been a truly illuminating dive into the specialized matrix of modern software. To summarize our key insight, today's enterprise architecture is fundamentally defined by highly specialized microservices built in whatever language is best for the task, all orchestrated by containers.
Yeah.
The architectural complexity is there because it's necessary to handle these specific high-demand tasks, from scraping web metadata and serving video with UnionFS to processing real-time telemetry with Signal-R.
And if you look at the core of all three, from the prompt architect standardizing AI input to VxCare predicting system failures, the most valuable component in enterprise architecture today is shifting. It's no longer just about storing content.
Right.
It's about intelligently processing it, enriching it, acting on it instantly, and ultimately using it to predict the future.
The architecture is now defined by the level of intelligence and autonomy it needs to achieve.
And this leads us to our final thought for you to ponder. The roadmaps we've seen show a clear, really aggressive path toward fully autonomous system management and teaching. Given that the video portal plans to integrate AI tutors and the fleet platform plans for predictive maintenance, what existing platform that you rely on right now, maybe in finance, healthcare, logistics, could be completely revolutionized by integrating a single, specialized, autonomous AI microservice? That's the strategic question to consider as you look ahead.
We'll leave you with that thought. Thanks for diving deep with us. We'll see you next time.